Well, thank you very much indeed for that introduction and for the invitation to come and speak to you. Last time I think I was at this meeting, it was just up the road and there'd been snow and most of the American delegates couldn't get here and all that sort of thing. So fortunately, none of that this time. Anyway, I want to take you on a journey for dietary assessment, and I hope you will forgive me for just tweaking the title a little to broaden out from wearables. Where is that little pointery thing? Is it? Oh, maybe it's here. No? Well, never mind. Do you see it as a pointer? I quite like using a pointer because it helps me to direct it to you. It was working, wasn't it?
Maybe the battery's gone.
Well, anyway, never mind. But yes, I'd like to sort of broaden out. So from just wearables, and we've heard a very nice focused talk from our last speaker on the work that he'd done, to think a little bit more broadly about dietary intake assessment using technologies altogether. Oh, it was turned off. Ah, thank you. Sorry. Oh, yeah, obviously, if it doesn't work, turn it on, switch it on and switch it off. Right. Here's my disclosure, and right from the start, I do have a conflict of interest, but hopefully in a positive direction. The work that we've done in my research group, funded by the Medical Research Council, we've now taken that to a small spin-out company. We aren't making a profit, but we, obviously we might, I suppose, in the future, to support our online dietary assessment tool called Dietary Assessment Limited, and these are the funding sources of relevance. So I'm going to be talking a little bit about challenges of measuring diet, thinking about both wearables and online and apps, and having obviously to touch briefly on new forms of data so that we can see how we're going to start improving our standards. You're probably familiar, and I think, again, last time I was here, some of these reports were just coming out, 40 years of federal nutrition research fatally flawed, failure to measure dietary intake. This is a more recent paper, but lots of criticism around what has been done in the past using self-reported dietary intake measures. So we do need to do better. There's an imperative here. We do need to acknowledge limitations of past studies and suggest ways of doing things better, developing and improving new methods. And we need to improve because we can't adequately, as a researcher, I want to really tie down what components of diet, what nutrients are associated with our key health outcomes, including obesity. It's sort of obvious, but it's so hard to do that. The systematic reviews that we have give such variation in results, making it really hard to be absolutely clear to the consumer. And so we need to do that because we've got poor precision of existing measures. We know that there are complex aspects cognitively of recalling diet if you're relying on self-report. And there are no real true reference methods. The doubly labelled water is one of those methods that we can use, but what is the biomarker for dietary fibre, for example? That we just don't have enough of those key reference methods. So we are a bit in the dark in some of these areas. I'm going to be focusing, as I've said, on online tools, apps, touching a bit on photographic methods and wearables. There are a whole lot of other types of information that we could use, new methods that might be relevant to dietary assessment. Twitter, I think I mentioned that last time, census data, town planning data even for sort of pathway walking, things like that. And then metabolomics coming through. Anyway, lots of different types, but I'm not covering those, you'll be glad to hear. So where have we come from? Even, over the last 20 years, there's been a big change, And you know, we are beginning to come out of the dark ages of pencil and paper. That is, researchers are, but when it comes to our healthcare professionals, they still only, at least in the UK, still only have pencil and paper to rely on. There's no validated apps available on our NHS store that will allow users to measure their food nutrient intake. But the US obviously was one of the first there with the ACET 24. You remember PDAs, no one uses them anymore, so that's a technology that's gone out of the window. We've had online food frequency questionnaires, the TADAR, scanners, e-button, and now into sort of more wearables. So we are beginning to cross a technology divide, and thanks to Alison Eldridge for this slide. But we're not there yet, and so some of these more traditional methods, potentially higher quality, or were they higher quality actually? Was there such a problem with the self-report angle that the quality wasn't really there? That's just something to think about. We now have obviously other digital images, passive data collection, sensor technologies, lower burden for the participant, lower cost, possibly better access for everyone. But is the quality there? Still, we're not sure. Anyway, I want to focus a little bit on a review that we've published last week or something, very hot off the press, that I was involved with Alison Eldridge and a team. It's an ILSI review sponsored to explore new technology-based tools for dietary intake assessment and to come up with some standards really for how these should be developed in future. So we did a large literature review. We screened a large number of articles. We only, in the end, ended up with 43 tools, but that's, don't forget, we're not talking about only 43 tools there. This is just 43 tools where there's been a validation study published in the academic literature. So clearly there are far more apps and so on than that. We identified 3 main types of tool, smartphone apps, PC or web-based tools, and a couple of wearables. And then there were what I've called app wearable combinations, and really I suspect that's where the market is going to be growing. So there was Food Now Australia, which had a wearable armband for energy expenditure as well as an associated app, and the Diabetic's Diary from Norway, which was a smartphone app paired with a Pebble smartwatch. So just to wake you up, because I know it's hard in these things to keep listening and I'm trying to be animated, how many of you have a smartphone app that you've used to record your food and nutrient intake? Probably MyFitnessPal or something like that. Yeah, and how many of you have got a Fitbit that you might use to track your physical activity? I haven't. Yeah, so, you know, maybe up to a half of the audience has got some experience with these tools, and it'd be interesting, we haven't got time now to discuss this, but you know, how often do you use it? Is it a bit of a flash in the pan? Is this something that's helped you in any way? How has it helped you? Anyway, those aren't questions that I'm going to ask you to answer now. So from our review, we came up with a number of challenges. Well, I've sort of synthesized this from the review in terms of data entry, food identification, what is the food, food description, it's not quite the same as identification, so details, you know, how is it cooked, that kind of thing, food composition, databases, nutrient and food outputs, lack of customizable systems, and lack of validation. And I'll just give you a slide or two on each of those. So data entry aspects, most of the tools that we reviewed relied on self-report, self-entry. Some were using digital imaging to help identify foods, but and then thinking about the next steps for use of these tools that were integrated, measuring diet and health in some way, were completely lacking. The data entry innovation that's been occurring, mostly around food photography, and we may hear more about that later. You need to have robust recognition of the food item. You need to have good estimation of the portion size, and then that needs to be linked to a detailed nutrition database to pick up the actual foods and nutrients associated with those foods. So digital images may ease respondent burden, but most still required text to be added to that. You know, I've seen some lovely systems where you can photograph a banana and it says, yes, this is a banana, this is how big the banana is, how much it weighs. You can cut a random piece off that banana and the system can say, yes, it's still a banana and this is how much it weighs. But I can guarantee, were you to provide it with whatever it was we had for breakfast, hash browns and something, yeah, it wouldn't try. Although, actually, having said that, and I'm getting a bit into whatever, my phone broke recently and I had to get a new phone, and I've got this, well, Motorola thing, and I only use it for, you know, taking pictures, whatever, where I am, emails, what have you. But it's got Google Lens on it. Have you used or seen Google Lens? Well, if you have it, or I didn't even know I had it, I just pressed a button and there it was. And so the picture that I took, my son's got a dog, I'm trying not to ramble, but it's a Portuguese water dog, which is an unusual dog. So you could press Google Lens and then it would offer you what type of dog it thought it was. And it was right. So I thought, right, okay, I'll take a picture of my lunch then, which was some sort of slightly random pasta dish with bits of chicken and whatnot in it and pesto. Could it identify that? Not so well, unfortunately. I think I got prawns as an offer and one thing of pasta. So it was getting there. And then my colleague's cup of tea, which could have been coffee, actually. I think, was it coffee? Anyway, whichever it was, it knew it was tea. It said, that's tea. So we're getting somewhere where we could perhaps start integrating those. Anyway, that's not a scientific thing, but you might have Google Lens on your phone. Have a look at it. So food identification, most again in this review were relying on manual identification of foods. People had to say what they were. And unbelievably, to be frank, not all of them had integrated databases for estimating energy or nutrients. I mean, how unhelpful is it if you're recording what you've eaten and it can't tell you what that means in terms of, you know, nutrition, really. Food descriptions, again, more on the photography side of things. Food image identification technologies are improving, as I've described, and our quantity estimations, but they can't replace some self-entry or checking. I thought I would just introduce a little mention of now options for novel classification strategies for image recognition, and I think that's what the Google Lens must rely on, is this sort of deep learning based approach with layers and layers, so it kind of searches through, looking at the outline of the picture, looking at different features of the picture, color, texture, shape, and providing a final layer for classification. So there were sort of some early versions where you would tell it something about what it was looking at, but now there's these very fully automated systems. So this is coming forwards. Food composition databases are another big challenge, and in Europe they're trying to put forward something called FoodX2, which is highly complex system of food classification, and in my opinion is not particularly useful for nutrition information, because it's trying to capture so many other things. There may be others in the audience who disagree with me there, but it's trying to do so many things in terms of aspects of chemicals, toxicology, as well as trying to look at nutrient composition and exposure assessments. So I think countries that have tried to apply that food coding system to foods have struggled to do it. Most of the tools that we have where you're linking to a food composition database are using national databases and national generic databases. In the UK, we have McCann Widdowson. But these are limited, 3,000 foods. That's not the same as the 50,000 foods that you have access to every day on your supermarket shelves. So brand level details are now becoming more popular. But And that's proved a challenge because not all brand owners want to share their data. And so people have turned to crowdsourcing. But there's a real challenge with that in terms of missing data. So just to pick up on that, the MyFitnessPal calorie counter, I just picked this out because it's an extremely popular tool, but it didn't take me very long to find whole areas where information was missing. You know, maybe you can't buy these anymore, I don't know, lark burger, parmesan, truffle fries. Well, total fat's in there, but the type of fat's not in there, nothing on other nutrients, and walnuts, which you'd think would be a generic one. Again, lots of missing information. So I'm not saying any database is complete, but relying on crowdsourcing might, at least you need to be aware of that as a possibility. Something that we've been doing is trying to map brand level information to our detailed and accurate generic food composition table, and we've done that for around 45,000 food items so that we can fill in what we have the back of pack declared nutrient information, and that needs cleaning actually quite a lot before you can make use of it, to then add in all the missing nutrients, and we've done that for our online dietary assessment tool. Outputs are limited, and some don't even generate automatic reports. Most are reporting on energy, but you see, it's not all of them even give you energy, as I said. That was quite surprising. Very few really reporting on micronutrients at all. And how reliable is that output data then? May well be unreliable. This is from a published review of the top diet apps from the Australian side of things. I was involved with this project, and we put into each app the same 3-day food diary to look at the differences in energy intake estimated by each of those apps compared to the gold standard system. And although overall the difference was relatively small, but if you were using a very popular app, Calorie Counter by Fat Secret, you could be overestimating your intake by 3,000 kilojoules. I did write down what that was in terms of calories. What is it? 715 calories. Or Point Tracker's Weight Watchers, very popular again, 2,000 kilojoules, 500 calories. So that makes a big difference if you're trying to lose weight. Any customization possible in terms of recipes, use of supplements? Most didn't have that option. And again, validation of the systems, only 6 studies had comparisons to doubly labelled water or independent biomarkers. Usability is something that also needs to be considered in these systems. To then tell you a little bit about the validation of the MyFood24 tool that we've developed in my research group, we have this tool now. It's for use in research. You can use it in a whole classroom setting, and we're working towards a health version as well. We have it in UK, German and Danish with relevant food composition tables, tube feeds, sip feeds, baby foods, etc., as well as generic products. But when we were developing it, and this is what some of the screens look like, when we were developing it, we undertook a detailed validation study with over 200 participants, independent biomarkers, and we compared our MyFood24 with the Oxford WebQ, which has been used in the very large biobank study, and a multiple pass interviewer recall, perhaps the gold standard. And these were compared to the biomarkers, which there was a range of sodium, potassium, urinary nitrogen, sucrose, fructose, etc. 3 measures were obtained. Overall, the MyFood24, the online tool, gave similar results to the much more costly and time-consuming interviewer-based multiple pass recall. So although we couldn't say it was better, at least it wasn't worse in this situation. We'd have liked it to have been better, but it wasn't worse, and it was similar. And the dietary assessment approaches from from both the MyFood24 and the interviewer-based recall, well, in fact all of them, led to attenuation compared to the biomarkers. But intakes were reasonable, and I've just provided our UK National Diet Nutrition Survey results there for men and women as a comparison. What about wearables? I know I promised to mention them, and we've seen how that market is growing. I've just got a little picture here, and I must say, even the thought of wearing 15 different wearables to do that test, a question I might have for our previous speaker is, well, how far up the arm did that go? My arm's not that long. I don't know how that would work. But anyway, so you can put things in your ears for chewing, around your neck for swallowing, metabolic sensors on your arms, on your wrist for monitoring, how many times you put your spoon to your mouth. You could have external video cameras to look at, have you got food on the table? Are you sitting down to eat it? That kind of thing. So these wearables could look at timing of eating, duration of eating, rate of eating, how much you've eaten. Can they be used for nutrient and energy intakes? Well, we're moving towards that. Here are some examples of the different chewing and swallowing around the neck. There are some that combine chewing and swallowing, and the visual and the inertial wrist motion tracking as well. I won't give much attention to this in light of time, and actually it's rather interesting because this feels like it's a similar study to the one that was described before, with 4 consumer devices and 2 sort of research grade devices compared to indirect calorimetry. And like the previous study that we heard about, these were all showing under reporting compared to the indirect calorimetry. So that the consumer wearables are not bad, but not yet equivalent to the best research devices, and they all have this negative bias. So independent quality standards, I think, would be very helpful to be developed. Wearable oral electronics, here is a thin breathable membrane that you could put in the mouth that can measure salt intake, so it might be useful for people with hypertension and so on. I don't know if I would want to wear that long term, but maybe I would if I was really trying to change my diet. There's a nice little thing here from Tufts, which could potentially, well, says it can track glucose, salt and alcohol. So beginning to, again, imagine cleaning that. There's practicalities there, isn't there? Here's the wearable monitor that could tell you, well, how many, it's not really how many bites actually, this one, it seems to me, but that's what they said. And bites apparently roughly correlates with calorie intake, but I think the word roughly is probably appropriate here. It is only roughly. And as we heard, sensors do need testing in field tests, not just the laboratory, because they do seem to be working differently if in the field to the laboratory. So lab experiments were not reflecting real-life behavior for meal microstructure and so on. New forms of data, I'll just skim past this, but I think it's so important and gives us the potential to do so much more. But how reliable is that? And we know that the amount of data that we have available to us is doubling every 2 years, so it becomes something that we can really do more with. Priorities for action in terms of big data. I put this here because I think I just got a little bit of a bee in my bonnet about sharing food data. Companies need to share food data so that we can track changes in population intakes for public health. Now, I know there's, people are shy about doing that because of potential commercial sensitivity and so on. But if there could be some kind of independent area where we weren't naming and shaming, we just need to track that sales data, that composition data, so that we can see how our population intakes are varying and how that is impacting on health. That's only got to be a good thing, and I'm involved with a project with the World Health Organization, who are trying to open up this whole area for discussion. So if you were wanting to choose a dietary assessment tool, which one is right for you? And we've developed this website called NutriTools, which should help researchers and others to choose the best tool for use in research or teaching. We do have a food questionnaire creator on there if you can't find the right tool for you. It has a library of international dietary assessment tools in there and summarises the validation of the tools with a way through in terms of best practice guidelines to help you choose them. Here we focused, because it was UK funded, we focused on UK validated tools first, but we do have 10 validated American tools on there. There's 127 tools on the website worldwide. And to help you try and choose which tool might be good for you, we have some bubble plots and summary plots. Each one of these represents a different study, size, type of different colours represent the different types of tool and so on, and how they compare to each other. So my summary slide then. Measuring food and nutrient intakes in populations is difficult, and methods that we currently have limit our ability to link diet to health. Use of well-designed and tested tools, including wearables, could help to give us a step change in our ability to reliably characterise food and nutrient intake in population studies. But I leave you with a word of caution from our lovely biostatistician Darren Greenwood. Is it better to be roughly right with small data than precisely wrong with big data? And these are some of the people who've been involved in the work, and thank you very much.